Good evening, everyone. I'm Kumar. I'm a final year student pursuing my BTech in Naval Architecture and Ocean Engineering at IIT Madras. I'm currently a summer intern at the Maritime Research Center. My internship project is titled Marine Heatwave Drivers, Predictability, and Fisheries Impact in the Bay of Bengal. The primary objective of my project is to understand the environmental drivers responsible for marine heatwave formation in the Bay of Bengal. Once these drivers are identified, the long-term goal is to develop a prediction framework that can eventually support fisheries and climate-related decision making. So before we even go into the project, let's first understand what a marine heat wave actually is. Uh, Marine heat waves are prolonged duration in which the sea surface temperature remains significantly warmer than the long-term average for at least 5 consecutive days. In simpler terms, they are similar to heat waves over land, except that they occur in the ocean. Over the last few decades, the frequency, duration, and the intensity of the marine heat waves have increased considerably. One of the major factors is global climatic change, which has caused the average ocean temperature itself to increase. Because marine heat waves influence both the ocean and the atmosphere, understanding their formation is not only an oceanographic problem but also a climate science problem. The outcome of this project are relevant to several stakeholders, one of the major stakeholders being the fisheries and the aquaculture sector. Marine heat waves can cause fish to migrate to cooler waters, change their distribution, and reduce fish availability in traditional fishing grounds. If these events are predicted in advance, fisheries can better plan their operation and reduce economic losses. Climate and weather agencies can use this information to improve monitoring and forecasting of ocean conditions. Environmental agencies can identify vulnerable marine ecosystems and plan controls. Researchers can be benefited by this work as this work contributes to a better understanding of ocean and atmosphere interactions, while policymakers can use these findings to support climate adaptation strategies and sustainable management of marine resources. Ultimately, if marine heat waves can be predicted with reasonable accuracy, decisions are made proactively. A review of existing literature shows that several environmental parameters are believed to influence marine heat waves. These include local parameters such as wind speed and surface heat fluxes, as well as a large-scale climate phenomena such as ENSO, the Indian Ocean Dipole, and the BSISO. The challenge is that different studies often identify different major drivers. Some suggest wind plays a major role, while others say that the heat flux. Another limitation is that many studies analyze only one or two parameters at a time. This makes it difficult to compare the relative importance of different drivers within a single framework. In addition, the Bay of Bengal is not a homogeneous basin. The northern, the central, and the southern regions have different oceanographic characteristics and are influenced by different atmospheric processes. Therefore, analyzing the entire basin as a single region may hide important regional differences. The objective of this project is therefore to build a comprehensive framework that analyzes multiple environmental drivers together and identify which one of them are strongly associated with the marine heatwave formation in different parts of the Bay of Bengal. To achieve this objective, I've adopted the following framework. The first step was collecting all the required data sets. Sea surface temperature forms the foundation of this work because marine heat waves are identified based on SST. Along with SST, I also collected the environmental data sets, which are wind speed and the surface heat flux. Once SST was collected, marine heat waves were detected using the Hobbs definition, which is internationally accepted standard for identifying marine heat wave events. To better understand regional variability, Bengal was divided into three regions: North, Central, and South. After identifying the marine heatwave events, I analyzed how each environmental parameter behaved before and during the marine heatwave event. By comparing these parameters with the detected marine heatwaves, we can identify which environmental factors are most strongly associated with the occurrence. Using the methodology I just described, I've completed the first major phase of the project. I processed 20 years of SST data covering the period of 2006 to 2025. Using the Hoppler definition, I identified a total of 117 marine heatwave events across the Bay of Bengal. Using the analysis completed so far, a few interesting observations have emerged. The most significant result obtained so far from the wind analysis. Across all the marine heatwave events analyzed, approximately 80% of the marine heatwaves were occurred during weaker than normal wind conditions. This result is also physically consistent with our understanding of ocean processes. Under normal conditions, wind promotes vertical mixing between the warm surface layer and the cooler water below. When the wind speed decreases, the mixing becomes weaker, allowing the warm surface layer to retain more heat. This creates a favorable condition for the marine heatwave development. In addition to wind, I also analyze the latent heat flux and sensible heat flux. These heat fluxes do change during the marine heatwave event, but unlike wind, their behavior varies from region to region. Some marine heat waves are associated with reduced heat loss, while others show enhanced heat loss. Therefore, based on the current analysis, heat fluxes do not exhibit as clear or consistent relationship with marine heatwave occurrence as wind speed. The next stage of the project will focus on analyzing large-scale climate drivers. After completing the analysis of the indices mentioned, the next objective will be to combine all of the local and large-scale drivers to determine which combinations are more strongly associated with the marine heatwave formation. Finally, these environmental parameters will be used as input to a machine learning model for marine heat. In the longer term, the prediction framework can also be extended to investigate potential impacts on fisheries and marine ecosystems. That's it from my side. Thank you all for your time.